Hello, everyone. I'm Marcel Veselka from Wopee.io, and I would like to talk today about AI testing agent. And this will be just a very short and simple introduction about AI agents and how they are coming to the testing. So let me start first with a very short agenda. I would like to talk about LLM apps and AI agents as an introduction, as a starting point before we will go into some more details. Then I will move on to some AI agent building blocks, because this will be necessary to build our AI testing agents. Then I'll be talking about AI testing agents, some definitions, and then we'll move on to some more hands-on and practical part where I would like to show you two live demos. If you're interested to these topics, please scan the code and register for our early access. I'm happy to talk to you about more details later. I will be presenting this QR code also later during the today. So let's start with the first point on my list. So LLM apps and AI agents. So what these terms means? LLM, it stands for large language models. And last couple of months or maybe even years, we are building already apps which integrates a lot of LLMs. Before we were using machine learning or other approaches from this AI world, but now generative AI is blowing up and everybody is building LLM apps. So let me start with that as a short definition. So what are the LLM apps, or sometimes we call them also workflows? They are basically systems which combines LLMs with algorithms. So what does it mean? That you use your traditional scripting approach or develop your code, but you also combine these approaches with your LLM. This allow you to solve some domain-specific tasks, which were pretty complex, by using simple algorithms or a simple coding approach. And as we keep using more and more LLM integration into our apps, there are multiple architectures or approaches how you could do that. My goal is not to cover all the details and all the specifics, but I would like to just maybe mention that you could find some ideas about this topic on Anthropic website, and I just pull out from the documentation or blog post these 6 specific architectures or approaches. The first one is very simple one, and you could use it already now with standard OpenAI API, or also I believe Anthropic could offer very similar approach. I'll be using OpenAI for my demo today. So you have LLM where you provide a prompt, and at the end you are getting output with some results, basically text to text. But you could enrich this by using some other features or tools, like some memories or some databases and tools. I will be covering this topic later. Let me just quickly go through the other 6 approaches. And this is basically the most simple one. And then you could get some more advanced or enhanced approaches, like chaining the workflows or running them in parallel, or combining these parallel runs and creating some aggregated outputs, and so on and so on. So the latest one, or maybe the biggest buzz, is now going about autonomous agents, which is basically the last and 6th level or a type of architecture, where a human is providing some high-level task, and then LLM agent is able to decide which tools will be used. I'll be covering this in more detail, but basically, if you're interested in these 6, the key point here is that you could read a lot of more in that Anthropic research page. And actually, my goal is just introduce the basics. And this will be very short webinar to do so. So these are the LLM applications. And as we are advancing and improving the way how we are integrating LLM into our applications, as I said, the latest or last discussion is about AI agents. So what are the AI agents? Basic LLMs are not able to take any action. So my short definition, and there are plenty of definitions, I'll be talking about this mess in terminology soon, but my definition, or the definition I really like most, is that AI agents are the LLM workflows which are able to take an action. And this action might be interacting with web, maybe sending out the email or calling API. We will be talking about that. Without this feature or this behavior, LLMs alone would be able to only generate text or do some reasoning, which are pretty powerful features we are using to build an AI agent, but this is not enough. So how it works? in short, we could say that you could provide a high-level task and then use LLM for reasoning and decision which actions need to be taken. So we are not guiding LLM through that process. We are asking LLM to plan and decide what actions to take and then execute these actions. And if you run this flow autonomously and in some iterations, then you are getting AI agent. So in short, AI agents combine LLM planning ability with tools or actions, if you wish, that help us to basically cover the gap between reasoning and real world execution. So we could do very interesting, or we can build very interesting applications, but with this LLM enrichment. But this is still a bit theoretical, so I would like to move on and soon explain this or cover that topic in more details. So if you remember these 6 various architecture approaches, on one side, you are having something very similar, where you send that prompt into LLM, and then you are getting some response. And you keep enhancing these, running it in parallel and so on. So you have pretty good control what will happen. But if you let your LLM decide what steps should be taken first, what will be the next, and how all this will work, you are getting fully autonomous tool, which we call AI agent, but the control there is pretty limited. I'll be explaining that very soon. And this brings me into one, maybe from this theoretical part, into one more, I would say, fairy tale type of explanation. We are talking about bots, robots, automation scripts, agents, and so on. And the terminology is these days pretty broken. A lot of people talking about this, but when the very clean or the pure definition of this is that agent is automated tool which is able to decide by themselves and take an action. So this, until it's not fully autonomous, it is not agent. Sometimes people also call some LLM-powered bots as agents, and we also do that, but probably you heard about something like AI drift, where we are moving with terminology somewhere else, but to be perfect in terminology, we shouldn't call any tool agent until it's not fully autonomous. And this is interesting topic to talk and discuss, to talk about and discuss with my friends, because we are building autonomous testing bots, which is sometimes a bit confusing because if it's fully autonomous, and it's not bot anymore, but it's more agent, so that's a bit messy terminologies. But let's move back to the definitions before I will explain how these tools works. So if you would go to Hugging Face and read the documentation, you might find some agency levels, which is pretty related to the topic I was talking about. I don't want to spend too much time on it. This is something that might be interesting for you. And if you're interested, go there. Similar definitions, similar, not the same, are published also on the LangChain page, which is another framework you could use for AI agent if you want to build an AI agent. And there are also some 6 levels of autonomy in LLM application, where we start with simple coding with no LLM at all, and then keep adding more and more LLM and enhancing the application behavior as we are adding more, how to say that, freedom to our AI-powered tools. At the end, we have autonomous LLM app. Sometimes people call agent, but as I said, it might be a bit messy. This brings me into another topic I was talking about maybe 2 years ago, first time, maybe 3 years ago, and this is autonomous testing. I'm talking about AI agents, but now let me step aside and tell you or just repeat what I already prepared in the past. I just copy paste one slide because that's something what might be interesting for you. In test automation or in testing in general, we are talking about autonomous testing levels, and there are 6. So the manual testing is autonomous testing level 0, and then we have some testers assistance, partial automation, then conditional automation, high automation, and then fully autonomous testing. And with these AI agents, building the automated test tools is super easy. And I'll show you some demos soon how to do that. But before that, let's now move on to AI agents again. And I would like to cover or explain what are the building blocks we need to understand if we want to build some AI agent or AI testing agent. And already in these examples, I will be using more testing related examples. So you will see how it fits into our testing topic. So There are basically 4 building blocks I would like to talk about. First one is planning and reflection. This is probably one thing which distinguish AI agent from all the other LLM workflows, because independent planning and reflection is something which makes the LLM tool super powerful, and we call it AI agent. Then there are some tools. We could use these, or we used to use that in the past as a part of LLM apps. Then there are memory or memories. And last, but I'm not sure whether this is a building block or rather some pattern implementation pattern we could use, is multi-agent architectures. I'll just quickly mention that at the end. If you're interested, I'll give you some tips where to read more about that. As I said, this is intro. So let's start with the planning and reflection. So planning and reflection is the first building block and probably the most attractive and important when you are building AI agent, because what it does as a functionality, it is able, or the agent itself is able to break large tasks into some small subtasks or sub-goals. And this helps us to reduce complexity and improves efficiency of the entire process, of the entire task which need to be conducted or done by the AI agent. And another interesting behavior of our AI agent is reflection and refinement, which means that agents are able to criticize themselves or the actions they took. They could learn from the mistakes or the failures and then refine their approach. And this is the process which helps us to improve the overall outcomes or results. And this sounds a bit maybe complicated how I could build this, but I could tell you this is already solved. You just need to know which tools or frameworks to use to build your AI agent, and this is just a matter of decision. You just say, okay, I would like to use this type of algorithm. And there are multiple algorithms, and some are more common, some not, but I just list out a couple of these algorithms. Very popular and often used is chain of thoughts. So I decided that I'll show you on this simple example what does it mean and how it works. But there are some more. If you're interested, again, you can research maybe ChatGPT or Google it, but there are multiple other algorithms you could use to decompose your task or run some self-reflection. So let me quickly show you how this chain of thought work or what is behind, because it sounds maybe a bit scientific, but it is not. But before that, combining goal decomposition with reflection enables AI agent to tackle complex tasks and improve it over time. So this is basically the first building block. So if we are able to plan and reflect, or our AI agent is able to do that, then we can easily solve the complex task. And as the agent works over and over the same task or similar task, it could also improve. For that, we need to have also some other building blocks like memory and tools and so on. I will be talking later about, but this is basically the principle that the AI agent is able to plan and then self-reflect or self-criticize what it does wrong or where it failed. Let me move on to the explanation of this chain of thoughts. So what is this chain of thoughts? I have one slide where I copied only some already existing example, but in short, on the left side, you have a traditional approach where you ask some question or you ask to solve some mathematical problem and you are getting the answer. On the left, and then you try to ask again, and then you get another answer, but the output is incorrect. So what you could do, and I'll be talking about it later, you can fine tune your model or retrain your model. So you enforce the model to do some thinking around the task before you get the response. And based on some research, or there is some research you could also read if you're interested. People found that this helps to get better results. So in short, chain of thought prompting means that you enforce your model to not giving you straight away the number or the answer, but also provide some justification, some explanation how it get into that result. So many of these, as I said, many of these algorithms are already inbuilt in the AI agent frameworks, which you would probably use when you would build that. It's similar as with any other development. We are not using, I don't know, C code to build our low-level components. We are not building our own databases or anything like that. We are using frameworks to implement our solution. In this case, this could be provided by some framework. I will give you a couple of tips what frameworks you could try, experiment with to get some interesting results. So let me move on from this first topic, which was planning and reflection, into second one, and it's tools. When I'm talking about the tools, this is basically approach for LLM, how you could get some data which are not available in a training model. For instance, if you would like to know what is the weather, this is the typical example in many documentation. When you read the documentation, you can find many such examples. Or if you would be interested in I don't know, stock prices, you cannot get it from the training model from LLM model because it's not available there. Or the other tool might be some calculator, because we know that sometimes LLM is pretty damn on the calculations. So these tools help LLM to get some better results. So you can combine, you can imagine that it's something like your prompt with combination of some data, which could be considered as a context, and these are combined, and then you are getting back from your LLM generator results, considering this data providing by tool. So let me just quickly cover this topic. There are symbolic and neural tools. And if I would go into more details, symbolic tools are the tools where you could have your own algorithms, which could be something like Playwright, open a browser, or click on specific button, or fill some element. It could be also APIs. Again, in our testing world, it could be some get test data or something similar. But it could be also neural tools, which could be another LLM. It could be some other tool using LLM. For instance, you could analyze the image or generate test data and so on. Or it could be traditional machine learning models-based tools like linear regression or self-healing or classifying the failures and so on. So basically, these are the tools which are integrated into our LLM. I'll show you exact or example how this works. Then we have a third building block, which is memory. And this will, when I was preparing this slide, it looked a bit complicated, but I will simplify it at the end on the right side of the slide. When the animation finish, it'll be simple and I believe clear. So when we are talking about the memory, there are three types of memories: sensory, short-term, and long-term. If you are talking about the sensory, there are visual, audio, or touch. Then we have something like working memory, which in our case would be context, basically whatever you provided before, but it's limited with the context window. And you probably know what the context window means if you build some LLM application before. And then we have long-term, which could be declarative or procedural. But this sounds crazily theoretical. So let me now simplify it. So when I'm talking about this sensory memory, it's nothing else than prompt. It's basically simple prompt you are using to provide into your LLM. So whenever you pass the prompt into your LLM, then this is sensory memory. When I'm talking about the short-term memory, I'm talking about the chat, or sometimes we could say it's the session where we provide all the data, but it's limited with the context window. And when we are talking about long-term memory, this is basically everything which couldn't fit into context window and is not part of the prompt. And that are all the data we need to attach or integrate into our AI agent. And these data could be stored as a part of your training data in your LLM model. I will not cover this one because we nowadays are using a lot of LLMs models which are pre-built, and often it's the simplest way to do so. But then you could find out that this is still not good enough, and you want to fine-tune these foundational LLM models, or you would like to enrich that with some extra data, which we store in RAG. I will be talking about that very soon. RAG means retrieval augmented generation. And I will explain the principle there. But you could imagine that like some attached database to our LLM. So these are the memory parts. So let me now explain two more details about memory, which are not very maybe obvious or standard these days when you are used to use some chat for chatting with LLM. This is something you might not know. So retrieval augmented generation, what does it mean and how it works? So this basically help us to expand the memory. So if you cannot fit the data into your context window because the LLM has some certain limitation, the session cannot remember enough to fit it in, this helps you to improve the knowledge of your LLM by providing this data via some external, let's simplify and let's call it database. So if we don't have these, And if we don't have the RAG attached to LLM, the only data or only information we have available is the training data as a part of LLM. Okay, there is one exception. If you are using some tools that could enrich your context or your data, that would be another way. But if I would have simple LLM chat without any other tools, this is the only information I have is in the training data. With this RAG approach, I could retrieve relevant data. These are basically chunk of the data. You can imagine that as a huge PDF, and you know that page number 14 is relevant, so you can pull it in to your context or to a session, and then work with that. What we call augmenting the prompt with this context, and then we generate response using this combined context. So the prompt combined with the data you are pulling or retrieving from your database, and this database is often or it's vector database. So that's the way how we store the data there. So how it works, a very simple example. So I have a prompt which maybe asks something like, what are my last week's tasks? And of course, my LLM don't know. And I could have some API, this would be tool, to call some, I don't know, Jira task or something else. Or I could have a database or document store with all my meeting minutes. And I just collect specific meeting minutes. Let's imagine we had 3 important meetings or whatever number would be. And we just take these documents and push it to the generator aside with my or along with my prompt, and then I'm getting the response. So this is simple example or simple explanation how RAG works. We just enriching the prompt with adding some extra data which are relevant to the prompt. So it helps us to address the context size constraints, as I said, and it is the way how to provide only the necessary information on the fly as we generate the response. So we are getting the data online. So you could feed the database online and then getting the data back during the prompting or during the calling the LLM. So this is this part is related to the memory, and it is often not very clear. That's why I decided to cover that a bit more in more detail. Second part, or another topic, which might be also sometimes people asking me about this fine-tuning because of other products and how we are using fine-tuning. So I would like to now clarify or explain how it works. So if you have the basic, or sometimes we call it foundational model, you might be pretty happy about the results. But if you want to influence that model, for instance, you want to change the tone of voice, or if you want to get some very specific outputs or results from that, there are multiple options. One is that you basically define some schema, what output should it provide, and so on. But not always that's the good approach. So I would like to talk about fine-tuning. So you basically customize your, or any model, I would say, with your own data to get some better accuracy and consistency. And to do so, actually, I would like to recommend you, the link is horrible, but on that link, you can find a nice explanation about fine-tuning. From there, I took one screenshot here on the slide. That's why I'm mentioning it here. But basically, good practice is that you prepare 20 to 50 very high quality examples. What is the prompt and what you expect to be as a result? And once you have it, you need to prepare it in some format. Actually, this is just example from the video I mentioned, but you need to prepare it in JSON-L format, which is a format which could be taken by OpenAI. And this is the example how you could do that. You just upload that JSON-L format. And if you read the documentation from OpenAI, you can find all the details. Then you choose the model you want to train on top of, and then upload your data and train the model. And then you are getting better results from the model, which is pretty powerful. But if you want to have your flavor of answers, then this is the way how to do that. So this was the third building block. So we were talking about the tools, about planning and reasoning, and about the memory. And the last one, as I said, this might not be considered as a building block, but these days we are talking about multi-agents architectures. This is something which is popping up, and the main motivation here is that as we are splitting the tasks, or the big task, high-level task, into small chunks, same is valid for the agents. The agents should be small and focused, and then we are getting very precise or efficient approach how these agents could help us. So this is the way how to do that. You might have multiple approaches how to do that. You might have a single agent, or then some network where the agents talk each other, or you might have some manager, or sometimes people call it supervisor. So there is one main agent distributing the tasks and asking specific agents to deal with that. And then there are more and more approaches how to deal with it. And basically, you can imagine that if you have a, I don't know, development team, you might have one developer, one tester, one business analyst, and so on. And these roles might be specific agent. Sometimes you can split this even smaller pieces. So there is sub-agents within these roles. But this is the approach these days considered as a good practice. It might change as this AI is developing heavily. But these days, we are working on the approach of multi-agent architecture. So this is basically what I wanted to mention here. If you're interested in that topic, again, there is a link. You can go further with that. And as I said, all these pieces are not so important to be expert on them if you are building your first agent. But I think it's important to understand that these are the building blocks and understand high level how it works. Because if you understand how it works high level, you can use some tools which will help you to simplify the implementation. I just pull out a couple of these tools which might be interesting for you. My demo is built on top of Vercel AI SDK, the first one, but there is pretty interesting and nice Hugging Face small agent for those who are working with Python. The same is valid for LangGraph. It's built in Python, and there are a couple of more like Crew AI, again Python, and Llama Index, another one which could be used to build AI agents. If you are not a very big fan of coding, we didn't touch the code yet, then there is a N8N as a low-code automation platform for AI agents. Of course, there is Zapier and Make and many others who are trying to step into that market, but I feel, and I'm not expert on that this N8N has probably the best positions these days. It might change very quickly, but they are pushing that topic heavily. So these are the frameworks you could explore if you're interested in AI agent and you want to advance your knowledge. As I said, these are just basics, but let me now move on and talk about another thing or another chapter of this webinar. And this is AI testing agent. Again, very quick introduction. We will not spend too much time on it. I would like to just quickly give you a taste, and maybe after 1 hour or 40 minutes, you might decide whether you want to dig into more details or not. So what are the AI testing agents? And I'll try to follow the same or very similar approach as I did before for the AI agents, because that's nothing special here. We are just focused on some specific task, which is software testing. And in my case, in my demos, I will be focusing on web apps. But as I said, LLM alone can't take action. They only generate text or reasoning. That's the same as for AI agents, nothing special. But what might be a bit different here is that we are starting with this high-level task. So we have some high-level task. We plan it with LLM, which means we decompose and structure that, and then we execute the actions and then evaluate the outcomes. So these are basically 4 steps which could go over and over and iterate. And this is how the AI testing works. Maybe what's a difference from the previous AI agent is that the evaluation is important, how we could assess whether something is good enough or not. So AI testing agents are autonomous systems that use LLM to plan, execute, and verify or test with minimal human intervention. So this is, again, my quick definition, how we could say or explain the AI testing agent. So I would like to now move on. And I feel like we have a lot already on the plate. So let's maybe make it now less slide heavy. I still have some slides, but I would like to start with demos, which might be the exciting part of the webinar. So first demo is simple AI testing agent. And how I build it, I'll just first start with some simple schema, and then we will move on to some code and then live demo. So my simple testing agent does not use any special memory like RAG or fine-tune model. I just skip that. I'm using tools, and these are the tools. I have some tool called star testing. Then I'm getting some page elements. Then I have one tool for click, fill, select, analyze, report issue, and close browser. So these are my tools. So if I'm talking about this 4 building blocks, I'm trying to now simplify everything, and I'm just keeping planning and reasoning tools, and I'm skipping the idea of memory. Even I'm using context, I'm using some session memory and prompts and all these things, but I'm not touching fine tuning or any custom training or any rack database, anything like that, and combining all these together. And I'm using Playwright. I'm using OpenAI to run GPT-4, I think, in my implementation, and then I have Versal AI SDK to build it. So how it works? I have basically two prompts. One is, we call it system prompt, and this is basically explanation for my agent, what tools are available and what are the rules to use them. As I said, the agent is able to use the tools in order as it wish. It is able to run it as often as it wish, but I have some specific rules I am providing to the agent. And these are 9 items on my list, what I'm asking the agent to do. So I'm asking to run every session with calling the tool start testing. Any cookie banner, I'm asking to accept that. I'm also providing some context to the agent that whenever the locators are needed, then the tool should call get page elements tool to receive that. Then I had some issues with parallel run of filling form tool. So I am asking the agent not run this fill tool in parallel, because it could fill 5 tools in parallel, and it's a bit messy, and the test was failing. Then I had some problems with the locators, so I'm providing that the locators need to be unique. If you are using Playwright, you might know that if there are 2 locators or the 2 objects for the one locator is failing, you need to disable the strict mode, or how they call it, and so on. So I have a couple of more such rules, and these are pretty technical, and that should be valid for any AI testing agent. And they are not domain specific, I believe. If I didn't make any mistake, I didn't put any domain specific requirement there. Another prompt I have, it's user prompt. So I would like to test, and if you follow my webinars, you might know what app I will be using for that, but I would like to test valid login. So I'm providing the credentials, and I am asking the bot to test that scenario for me. So I'm saying that this is the QA senior or QA tester for testing the login procedure, and it should log in with credentials. Then I need to provide some, or I need to define the agent. So the agent itself is defined by using some very simple framework function, which is generate text, where I provide GPT-4o. Actually, this is provided from other Microsoft Azure, but you can use also direct OpenAI. Then I'm providing the prompts. Then you could see that there is a set of tools I'm providing to agent to use, and I'm not saying which tool, when, and how to use. Of course, I'm manipulating the behavior a bit by providing that rules via system prompt, but the agent itself will decide which tool to use. Then I have some tracking on after each step, which will finish. And then I'm telling agent, if you cannot complete in 30 steps, then stop. I don't want to wait forever. So we try to execute this using the tools and then provide some results. So now these are the basics. So what I would like to now do is that I will run the demo. It'll take maybe 1 or 2 minutes, but let me start with that. So on the left side, I have the screen with application under test, and on the right side, you can see a terminal with all the details. I don't know whether you can read the small characters there. That's why I just copy paste that steps which were executed into the middle. So it starts with start testing, then it get some list of elements, then it clicks on sign in, then it analyzes the screenshot, and it sees, aha, okay, I'm on the signing screen. So it starts filling that the first element, then analyze the screenshot again, and so on and so on. So if you are interested in that details, you can probably pause the video here or go there and back and see all the data or details. But this is basically how it works. And at the end, we should get something like agent finished with some results. And yes, and we are there. So at the very last row, you can see the login process was successful. Procedure of logout link. I cannot see that. Okay. The presence of logout link and the updated URL parameters confirm that blah 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 and so on. So this is the example. Of course, how we are validating that this is correct, how we work with that. There are multiple challenges and issues with this approach. As I said, this is a simple agent. So the only way how we validating that everything is correct, we are taking the screenshots, and from the screenshots, with this screenshot and analyze tool, we are analyzing what's on the screenshot, because that helps us to make sure that whatever step was conducted was successfully executed. And we also getting some context for the next step, so we know what to do next. So I think this might be not very good assert or very vague assert, and we need to improve that. But let me now maybe share with you some challenges I could see still there. So even I'm super excited about the small, simple testing agent, which works pretty well. It's able to log in, but it has some high maintenance overhead. Because when I was building it, there are small tweaks you need to play with to make sure that all the locators are correct and everything works as it should and so on. So you need to tweak your tools and maybe introduce some more to make sure it works. But this is still exciting task, and maybe you might like it. But what I found a bit challenging with this approach, that there is no repeatability. We are used to have some certain set of tests which are executed again and again. So with this approach, you need to implement that in some way. You could probably store that or have some agent to explore and first execute the test, and later maybe you could get back and rerun that. But in my simple testing agent, this is missing. This is probably not the challenge of the approach, but rather a challenge of my implementation or issue of my implementation. So also some traceability and debugging. I have not built in that any special reporting. I could maybe use the HTML report from Playwright, but I'm not using a test runner there, or I could use report portal or anything similar. Or this is also a pretty code heavy approach. So for some of you might feel like, okay, but I'm not developer, I'm tester. Even I like the test automation. This might be too heavy for me. And then scalability issues. So how I could maybe start testing this across multiple platforms and environments and so on. So why I'm talking about this, I believe all these could be handled internally as a part of your team. You can build super exciting, or you can introduce or start a super exciting testing agent project, or search for some tools. And I would like to show you in a second demo what we are building. I'm not touching all of these challenges, but many of these we are trying to remove by packaging this idea into our solution. And if you follow me, you probably know that last 3 years we are working on autonomous testing bots. As I said, it's now a bit confusing as the market is developing to the agents. So maybe we will need to rename autonomous testing agents. I don't know. But we are dealing with all these issues. And I will just quickly show you the second demo of these AI testing agents, and that would be with Wopee.io, how it works. So imagine that instead of this one simple agent, you might have multiple. You have some AI crawler. Basically, what I present could be just crawler, even there is some assessment, and we have something like that in our solution as well. But then you might have some business analyst, test developer, or SDET, and then some test executor. And all these agents could work together. And if you remember the architectures, you might easily now go back in a video and find out which type of architecture pattern we are following. We have something like test manager or orchestrator to organize all these. And we're still building a lot of stuff there, but we already have some certain pieces you could use, or certain agents you could use for your purpose. So, and apart from this, what I believe is super useful, that we are not running on the fly the test, but we are also generating some user stories, test cases, and test scripts. So rather than running that on the fly, which is super sexy, we are trying to store some artifacts, which you could revisit and see all the traceability, all the details there by scrolling through some of the UI, or we could also provide it via API. So how it works. The first item here is collecting HTML files and screenshots. This is basically crawler. Once you crawl that app under the test, then we generate the user stories, test cases, and test scripts. And then we can also execute them. It's not on the list, but basically we could have a test report at the end as another output. So how it works here. So what I did in our platform, I crawled the app I was also using for the previous demo, but there are a couple of more screenshots. There is some checkout page, some details about visual testing we also provide as well. And once I have it, I select that crowd data, and I use them as an input to generate user stories, test cases, and then at the end also code. So what's happening now is that I'm generating some app context. So this is basically one tool where we generate app context, then we generate the general user stories, and from that we generate very specific user stories you could use as a part of your project. You can integrate them or paste them into Jira or any other tracking tool as you wish. And then we generate from these user stories also test cases. You can see now the progress bar is spinning on the test cases. So once this is done, we could then use these tests to generate also the code. But first, let me show you the user stories. It looks like this. You can enhance them. Same for test cases. Again, you can manipulate them as you wish. Then you have, I just select the user login and generate the code out of it. And I could see that code is generated. And then I could run that code in our GitHub action. So basically everything is done, and I should see here the new run popping up very soon. And I could see that it might take some time because it's run externally on GitHub. But if we go to the actions, we could see that there is some job already running. And if I go there, I could see that that job just started and it's running this user login test. I could go into the GitHub and play with the code, or I could stay here and everything could be controlled from the front end. How this looks once the test finish, you would basically get a list of the steps with the screenshots, and you could see the report. As this is a visual testing powered, we have also non-visual testing assessment, but in this example, I'm using visual testing. All the screenshots end up in the status new. I would need to approve them, and whenever I rerun the test, then it checks the screenshot. Again, this is enhanced assessment. This does better job than just analyzing images using LLM. I'm not saying one or another is better or worse. It's important to understand when to use which one, but we could combine these with traditional assets, which could be also generated in the code, and we could also use this LLM analysis or screenshot analysis using LLM. So this is basically how our approach works. I believe it's much more mature and enhanced, and basically address almost all of the challenges I mentioned from the previous one, but you could still build it by your own. So I would like to maybe soon conclude, because we covered LLM apps, AI agents, AI testing agents, and then we had two live demos. And I would like to invite you to join us and be our early or very first, not very first, we have already some, but early user. And if you're interested, we are onboarding new users almost daily, but via some onboarding calls. So if you're interested, just register using this QR code or the URL. And I'm happy to talk to you about this AI agents. Also, if you're interested to enhance your existing tools or educate your team, I'm happy to talk to you. And we could deliver some workshop. Actually, I'm talking or delivering workshop on this automation days 2 to 3 weeks, I think, in Rotterdam in 3 weeks. And then I have a couple of talks in May as well in Madrid and Munich on some other testing events. And so I have also some online events. But if you're interested in these topics, I'm happy to talk to you to deliver some customized workshops or training on the idea, which would take 1 or 2 days, and empower your team with this knowledge as well. So some more tips for you if you're interested playing with other tools we are building. We have also Playwright AI bot, which basically wrapping up everything what I was demoing by UI into command line, and it's open source and free to use. So if you're interested, use this npm package, and you can easily run it on your site using OpenAI keys or any other models you would like to. Not any, but I think whatever is available in Azure or OpenAI, and we will keep adding more later based on the feedback from the users. So as I said, become our early user, and with that, I would really like to thank you all for joining me today. I hope you enjoyed the topic. Please subscribe, provide your questions in the comments. I will reply to them next upcoming days, and share this with your friends. I would love to talk as many as possible people about the topic, because I believe this is the future, and let's join and work together on the future testing. So see you and bye.